In this question, we are required to find an expression for this integral. Um, Now, before we start integrating it, uh, we have to check that the interval of convergence meets the required conditions that we already discussed about. We have to check that um, the limits are within the interval of convergence. So, from my previous examples, if you want to check my previous videos, we had already established, that the interval of convergence of this series is from -1 to 3, including -1. Okay, so basically what I'm trying to say here is we have already established, I've already worked this out in my previous videos, that the interval of convergence of this series is from -1 to 3. Hence, the limits are within the interval of convergence. Remember, the limits of this integral is from 2 to um, 2.5, and that's within 1 to 3. So we can go ahead and integrate it. Okay, so integral 2 to 5 over 2 the summation k is equals to 0 to infinity. Now you can pass the integral sign into the summation sign. I've already explained why in my previous videos. And I'm also going to do another thing. I'm going to factor out 1 over square root of k plus 1, because that can be good. We are integrating with respect to x. So this can be considered as a constant, if you want to say that. So 2, 5 over 2, x minus 2 to power k dx. All right, and this makes more sense. All right, it makes more sense. Anyway, we can go ahead and now use the reverse power rule. Remember, use power rule when you are differentiating. So when you're integrating, you're going to do the opposite of that. So x minus 2 to power k plus 1 over k plus 1. Okay, so what you'll end up with is 1 over square root of k plus 1 into bracket. Now, if you plug in oops, I forgot to write the limits here. This is 5 over 2. All right. This is 5 over 2. Anyway, what I meant is if you plug in the limits, you will end up with 5 over 2 minus 2, that will be a half. So that will be a half to power k plus 1 over k plus 1 minus, if you plug in 2, let's just end up with 0. So what we end up with is the sum from k is equals to 0 to infinity of 1 over square root of k plus 1 multiplied by half k to power k plus 1 over k plus 1. This guy can be simplified as summation from k is equals to 0 to infinity. Numerator, I can just leave it as a half to power k plus 1. The denominator, I can write it as k plus 1 to power 3 over 2, to power 1.5.